Today's video is going to be focusing on our last success criteria of Unit 1, which is to explain the relationship between mass and volume in terms of density. And today, we're really going to be focusing on the first checkbox, which is calculating density using derived units. In order to calculate density using derived units, we first have to know what density is. So what is density? Density is how much stuff is packed into an object's space. Or in other words, and in a more scientific language, it's how much matter is in a specified amount of volume. Now let's try to visualize density. Let's assume that this bowling ball and this volleyball have the same volume. Which means they both take up the same amount of space. But think about what you'd rather be tossed. Would you rather have your friend throw a bowling ball at you or a volleyball? I hope that you said volleyball, and you know why. It's because it's lighter, which means it has less mass. So the bowling ball, in contrast, has more mass. So we can say that the bowling ball has more mass per unit volume which means it is denser than the volleyball. In contrast, the volleyball has less mass per unit volume. Which means it is less dense than the bowling ball. You might also remember density in terms of sinking and floating from middle school, where if something is less dense, it'll float, but if it's more dense than the solution it's in, it'll sink. Now let's learn how to calculate density. And we're going to use something called a formula triangle. So we have a triangle here split up into three parts. D stands for density. And that's going to be in units of grams per cubic centimeter or grams per milliliter. M is going to go on top. It looks like a crown. And M stands for mass. And for us, we're only going to use the gram because that's what our balances measure. And in this bottom right corner, we have V, which stands for volume. And remember that we actually have two units for volume. We have cubic centimeters for regularly shaped objects, those cubic objects, or milliliters for irregular objects or liquids. And here's how you use this triangle. If we need to calculate something, we can use our thumb, and in this case, this rectangle, to cover up what we're trying to solve. So if a problem is asking to solve for density, we can cover up density with our thumb, and we're left with M over V, which means we're going to do mass divided by volume. If the problem asks us to solve for mass, we can cover up M. And because these two variables are next to each other, we're going to multiply density times volume. So these two things will be given in the problem. If the problem asks us to solve for volume, we cover up V, we have mass over density, so we would divide mass divided by density. So something to keep in mind are units, and this is something typically forgotten by students. Density is processed, which means we're going to be doing math using raw data, so its unit isn't simple. Instead, we utilize both of density's components, which remember are mass and volume, to determine its unit. So the unit is called a derived unit, and the process is called deriving units. So remembering that density is equal to mass over volume, mass is always going to be in grams, but if I have a regular solid, that means I've used cubic centimeters. So my volume unit is going to be cubic centimeters. So if I have grams per cubic centimeter, this is the unit I should have for a regular object when solving for its density. For an irregular object, remember that density is still mass over volume, and we're still going to be using grams for mass. But now I have an irregular solid or a liquid, so now I'm going to be using milliliters. So it'll be grams over milliliters. So whenever you solve for the density of an irregular object or a liquid, this should be the unit at the end. Now let's do some practice problems. So typically when I do word problems, I like to circle what I'm trying to find, so circle my unknown, and underline what I'm given. So that includes numbers and the unit. So in my first problem, it says, what would be the density of a soda if it has 700 grams of matter in a 350 milliliter container? So I see two numbers here. I have 700, and it's attached to the unit of grams, and 350, which is attached to the unit of milliliters. And after rereading the question, there's a question prompt, what would be, in front of density. So I'm solving for density here. So because I'm solving for density, I'm going to use my thumb to cover up D, and I'm left with mass over volume. So my formula is density is equal to mass over volume. So now I have to remember if grams is mass or volume. And if I look back at my notes, I see that grams is the unit for mass. So I'm going to have G right here, which means that this is volume. So I'm going to have 700 divided by 350. So after taking out my calculator, I know that's an answer of 2. And because my units are grams and milliliters, if I look back at my notes, density can be either in grams per cubic centimeters or grams per milliliters. I have to pick the unit that matches the units I'm given. So because I have grams over milliliters, my unit is going to be grams per milliliters. So because you guys are pretty proficient in math, I want you to try questions 2 and 3 on your own, and it'll be our next class's warm-up.